Welcome to part 1 of the review for experimental design. First, we're going to review population and sample. Remember that the population is a set of people or things that you want to know about. The sample is a set of units you do get to study, and a census is a special case where you collect data on the entire population. Now, going back to the first free response question I assigned, dealing with how students feel about the cafeteria lunch at Olympia High School, our population is the people or things we want to know about, which are the students at Olympia High School, all 3,000 of them. And from our population, we're going to take a sample of students that will actually study. And remember, that was around 100 students. So again, from our population, we're going to take a sample of students that we'll actually do the study on. Next, we're going to discuss the different types of bias. First, there's sampling bias. That is present if samples tend to be too high or too low in regards to the population parameters. Then there's also the voluntary response sample, which is a type of bias. Take, for instance, when a television or radio program asks people to call in and take sides on some issue, those who care about the issue will be overrepresented, and those who don't care much might not be represented at all. Then we have convenience sample. Units chosen are easy to include. Take, for instance, the first free response question I assigned when you went to the cafeteria and randomly selected every other so many students to ask them how they felt about lunch. That was convenient to do the sampling there, hence the convenience sample. And then we have a non-response bias, people who just refuse to answer a survey. Now I'll discuss probability sampling. Probability sampling is any sampling that uses some form of random selection. The first type of probability sampling we'll talk about is a simple random sample, SRS. The criteria for a simple random sample is that all possible samples of a given fixed size are equally likely, and all units have the same chance of belonging to the sample. How do we choose a simple random sample? The simplest way is to let chance choose your simple random sample by putting all the individuals from your population into a gigantic hat, mixing them thoroughly, and drawing individuals out one at a time until you have your sample. Next, you could use a random number table or a generator to choose units from the numbered list. Stratified random sample. This is the second type of probability sampling. If you can divide your population into subgroups that do not overlap and that cover the entire sampling frame, the subgroups are called strata. Here's a visual example of a stratified random sample. A company has a list of clients that come in 3 different ethnic backgrounds, Caucasians, African Americans, and Hispanic Americans. So they're able to break them up into subgroups and still represent the entire population of their client list. This is a nice visual of a stratified random sample. Why might you want to stratify a population? Well, first, it's convenient. Convenience in selecting the sampling is enhanced. It is easier to sample smaller, more compact groups, such as the male and female students at Olympia, than one large group spread out over a huge area, which would be all of the Olympia students. Coverage. Coverage of each stratum is assured. And precision. Precision of the results may be improved. That is, stratification tends to give estimates that are closer to the value for the entire population than does a simple random sample. This is a fundamental reason for stratification. Now we'll discuss some other methods of sampling, such as cluster samples. That is, selecting a simple random sample of clusters of units, such as a classroom of students, rather than individual units, the students. Here's a visual representation of cluster samples. We have our population broken into 6 different clusters. And from those 6 different clusters, we will randomly choose 2 of those clusters to represent our sample. And that is a visual representation of cluster samples. The steps in choosing a cluster sample. First, create a numbered list of all the clusters in your population. And 2, take a simple random sample of the clusters. And 3, obtain data on each individual in each cluster in your simple random sample. The last type of sampling we'll talk about is a systematic sample with a random start. This is a sample selected by taking every nth number of the population. An example would be starting out at a random spot, having people count off, and then picking one of the numbers at random. Okay, here's a visual representation of a systematic sample with a random start. So we'll have the people first start off by counting off, so they count off 1 to 12. And then we'll pick one of the numbers at random. In this case, it was person number 2. And then we decided to take every third person for our sample, the nth number, this being the third person. So every third, 1, 2, 3, so 5 is in our sample, along with 2 where we randomly started. And then 1, 2, 3, the 8th person is chosen as our sample, and then 9, 10, and 11th person is chosen to be in our sample. Again, this is a visual representation of a systematic sample with a random start. Thank you for joining me for the first part of our review for experimental design.